In this video, we're going to determine all 6 of our trigonometric ratios if we know that cosine of theta is equal to 3 over 5, and theta is an angle that's inside the first quadrant. Well, the first thing we want to do here is draw our xy plane, and we're going to draw an angle inside the first quadrant, and we're going to label it theta. We're going to create a right-angled triangle, and we know the ratio cosine of theta is 3 over 5. Now remember that cosine is the adjacent side of our angle over the hypotenuse. So we know that this length here is 3, and our hypotenuse's length must be 5. Let's use the Pythagorean theorem to find our missing side length. So we have that 5 squared is equal to the opposite side squared plus our adjacent side squared. So this means that 25 minus 9 must be equal to our opposite side squared. And simplifying, we're going to get that our opposite side is either plus or minus 4. Since this triangle is technically formed by this point up here in the first quadrant, we're going to take a positive 4 here, so that our point here is 3, 4. Okay, now that we know all 3 sides of our triangle, we should be able to determine all 6 of our trigonometric ratios. Well, our first ratio is cosine, and that's given to us in the question, so we know cosine theta is equal to 3 over 5. Next, let's try to determine sine of theta. Sine of theta is given as the opposite side over the hypotenuse. So sine of theta in this case is going to be 4 over 5. Next up we have tan theta, which is sine theta over cosine of theta. Or if we come to our reference angle, tan of theta is given as the opposite side over the adjacent side. So tan of theta should be 4 over 3. Next up is secant theta. This is 1 over cosine of theta. So a quick way to get this one is we take the ratio for cosine of theta and we take the reciprocal and we get 5 over 3. Cosecant theta is the reciprocal of sine theta, so we should get 5 over 4 here. And finally, cotangent of theta is the reciprocal of tangent theta, and here we get 3 over 4.